There we go. All right, you guys. So we've been talking about discrete and continuous relationships. And we've been talking about the domain and range of those relationships. Today we're going to bring it together and do some real-world problems. So on the front of the worksheet I just handed out to you, numbers 1 and 2 on the front, you guys are going to do. I want you to take a look at the back side. Numbers 3 and 4, we're going to do together as examples.
Why did you say 3 and 5?
It says 3 and 4. Number 3 says, you ready? A customer at a fireworks stand has $30. Sparklers are sold for $2 a box, and black cats are sold for $3 a box. If the customer would like to purchase a mixture of sparklers and black cats, how many of each can the customer purchase? Well, to find that out, I'm going to write myself a function. You ready? A function. Yes. So here, I've got sparklers are $2. So can I write 2F to tell me how much I'm going to spend on sparklers? Okay. And black cats are $3 a box. So plus 3B equals 30. Sorry. All right. Part B says, is this relationship discrete or continuous? All right. Well, hold on. Let's think back to yesterday. So remember yesterday I said continuous was where there's no jumps, gaps, or overlaps, right? Well, we won't have to worry about overlaps. And discrete was where usually we have a set of points, right? So like there's a bunch of points plotted. So here, let me think about this. So the number of boxes depend on one another, right? It depends on how many boxes of sparklers I buy. Will tell me how many boxes of black cats I can buy, right? So, can I buy 1 box of sparklers? Yes, right? Could I buy 7 boxes of sparklers? Yes. Could I buy 6.5 boxes of sparklers? Why not? You can't cut the box in half. If I go to H-E-B and say, you know what, I only want half of this bag of chips, I can't just like pour out half. Well, I can't pour out half the bag and go to the cash register and say, ring me up for just half of this, right? Right? Usually? You can't do that. But if you go to H-E-B, so that would be a discrete relationship, right? The number of bags. But what if I went to H-E-B and I decided I wanted to buy bananas? Because you can decide how many pounds of bananas you buy, right? Because you can take a banana off and be like, oh, that's too much, and take one off. Why not? Okay, or you can see a bunch of 5 bananas and be like, no, I only want 4, and you can go back and look for 4 bananas, right? So they're sold by the pound. Yes, ma'am. So they're sold by the pound, right? So that would be continuous, right? Because we could have half a pound, we could have a quarter of a pound, we could have a few ounces, right? Right? So when we can break it up into pieces, like if we're buying something by the pound, that would be continuous, right? But if we have to buy a whole number of something, like bags of chips, that's going to be discrete. So in this case, we can't buy parts of a box of fireworks. We have to buy whole numbers of boxes only, right? So this is going to be a discrete relationship. A discrete relationship. Discrete. So part C. So label the coordinate plane, graph the function, and identify the domain and range. So let's start with labeling our coordinate plane. So here on the bottom, I'm going to make this my S's. So S is my boxes of sparklers, right? So I'm going to label this sparklers. my y-axis is going to be B, my boxes of black cats. Black cats. Alright, so now, to graph this, what I want to do is I'm going to create a table. Because I know if it's discrete, I'm going to have a list of points, right? So let's start with a table and then plot those points. You ready? I'm going to make a table, so I'm going to have S for sparklers, B for black cats. So, if I have 0 boxes of sparklers, so here I'm going to have S times, oh wait, not S, 0 is S. 2 times 0 is my S, plus 3 times B equals 30, right? So what's 2 times 0? 0, so I have 0 plus 3B equals 30, right? So then 3B equals 30. So if I divide both sides by 3, how many boxes of black cats can I buy? 10. So when I buy 0 boxes of sparklers, I can buy 10 boxes of black cats. Right? Is that okay? That is a lot of black cats. Alright, what about when I buy 1 box of sparklers? So I'm going to come back. I'm going to erase this. There we go. So when I have 1, how much did I spend on sparklers? $2. So if I subtract 2 from both sides, I have 3B equals 28. Right? And then 3 goes into 28 how many times? Not dollars. That's numbers of boxes, right? So can I have 9.3 boxes?
No.
We can only have a whole number of boxes, right? So 9 boxes of black cats. Yes, so the more boxes of sparklers I buy, the less boxes of black cats I can buy, right? All right. Oh, you think so? Let's find out. You think so? Those are some really good predictions. Let's see if they are true. So when I buy 2 boxes of sparklers, I spent $4, right? So then 3B equals 26.
Yeah.
So 3 goes into 26 how many times? So B is 8. Because it's 8 point something, but we can't have a fraction of a box, right? What about when I buy 3 boxes of sparklers? You think it's 7? I want to check. All right, so I have 2 times 3 is 6, so I spent $6 on sparklers. So 3B is 24. So B is, I can buy 8, so that would be exactly $30, right? Ooh, so twice in 2 different cases I could buy 8 boxes of black cats, right? That's okay. We're going to plot it. Remember, does it have to be a function? Not necessarily, right? All right, 4. 4 boxes of sparklers. So if I buy 4 boxes of sparklers, I've spent $8 on sparklers. So then on black cats, 3 boxes of black cats, I have $22 to spend. 7.5, but we can't buy half a box, so we're going to say it's just 7. 5. Let's see if it evens out at 5. You think it's 7 again? Let's find out. Oh, I didn't mean to erase all that. That's okay. So when I have 5, that's 10 plus 3B equals 30. So then if I take 10 from both sides, 3B is 20. 7 again? Well, we would need 7 times 3 is 21, right? So it's got to be 6. So B is 6. We don't quite have enough to buy 7. Right? We're 10 cents short. Alright, so when I buy 6 boxes, that's $12. So 3B equals 18. So 3 goes into 18 how many times? 6. So I have 6. So when I have 6 boxes of sparklers, I can buy 6 boxes of Black Cats. 7 boxes of sparklers. You think this one's 5? So that's $14 on sparklers, right? So $3 times the number of boxes of Black Cats would be, what is that? 16? So 3 goes into 16 how many times? 5 times. So that gives me 15, which is almost enough. Which is almost all my money, I mean. 8. 8 boxes of sparklers. 5? 5 again? So that's $16. So that's 14. 5 times 3 is $15, right? We don't have enough. So it'd be 4.5, but can I have half of a box of Black Cats? No. So it's 4. 9. So 9 times 2 is 18. So 3B equals 12. So B is 4. 10. If I buy 10 boxes, of sparklers, so 3B is equal to 10, so I can spend $10 on Black Cat, so that's 3. 11 boxes of sparklers. We're gonna use up all of our money. Well, let's see. 11, that's 22, so that's $8. 3 goes into 8 how many times? Twice. 12 boxes of sparklers. That's $24, right? So that's 3B is 6. So how many boxes of Black Cats can I buy? 2. Then it's going to be 1. So 13, that's 26. So that's 3B is equal to 4. So it's just 1 box of Black Cats. So, can I buy 14 boxes of sparklers? Well, what's 14 times 2? 28. And would I have any money left over to buy any Black Cats? No, so it would be 0. Alright, so what I'm going to do is I'm going to plot those points, those 15 points, on my graph. Now, to make it easier to graph, what I'm going to do is I'm going to label every 5 lines. That way I don't have to count every time. Huh? You're going to count by 2s, but why would you count? Like every other one, like 2, like this?
That's too long. You got to do about 5.
10, 12, 14, 16. Okay. 2, 4, 6, 8, 10, 12, 14, 16. All right. So at 0, when x is 0, when s is 0, sorry, b is 10. When s is 1, b is 9. When s is 2, b is 8. When s is 3, b is 8. When s is 4, b is 7. When s is 5, b is 6. When s is 6, b is 6. When s is 7, b is 5. When s is 8, b is 4. When s is 9, b is 4. When s is 10, b is 3. Oh, I made a mistake. It's not this one, it's this one. I want to mark it out in blue. Not this one. Alright, so then 10 is 3, 11 is 2, 12 is 2, 13 is 1, 14 is 0. Question?
I'll check the answer.
Oh, okay. Alright, so part C says label the coordinate plane, graph the function, and identify the domain and range. So we graphed the function, we labeled the coordinate plane, so now we need to identify that domain and the range. So what I'm going to do, I'm going to say domain is, well here if it's discrete, am I going to write an inequality? Or am I going to list all of the x values? We're going to list the x values, you got it. No, because 1 through 14 would imply 1.5, 2.7, 3.9, right? So we have to list them. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Man, he should have spent less than $30, right? That would have made our job a lot easier. Alright, I'm out of room for my range. If y'all don't mind, I'm going to write my range right over here. Is that okay? Alright, and then what are my range values? 0, 1, 2, 3. Well, 0 through 10, right? Because I have all of them? That's okay. Did you count down? That's all right. That's okay. I ran out of room. That's all right. I'm okay. I'm okay. D. D says describe the meaning of the Y-intercept in this situation. So my Y-intercept, is that one on the horizontal or the vertical? Vertical. So that point is 0, 10. What does 0, 10 mean? The number of black cats I can buy when what? When you buy 0 sparklers. That was beautiful teamwork. Very nice. So I can buy 10 black cats when I buy 0 sparklers. So I'm going to write that. I'm going to say I can buy 10 black cats when I buy no sparklers. All right. I can buy 10 black cats when I buy no sparklers. All right, what about that X-intercept? What does the X-intercept mean?
You could buy 14 sparklers if you buy no black cats.
You can buy 14 sparklers if you buy no black cats. I can buy 14 sparklers because we have 14 sparklers when we buy no black cats.
I can buy 10 black cats when what?
Mm-hmm. I can buy, B-U-Y, 14 sparklers when I buy no black cats. Mm-hmm. So we have $2 left over, so maybe we can buy some poppers or something. But we're not worrying about that because we just wanted sparklers and black cats. That's what we came for.
No, but you're saying like you get 14 sparklers.
Uh-huh.
28, which still gets $2 to buy.
Yeah, so we still have $2 left over, but we can't buy any more.
Sparklers are $2. Yeah. Because you're saying
14.
The equation you're saying is that you're not going to buy any black cats on 3E.
Uh-huh.
That's when you're talking about you're not going to buy any black cats.
Uh-huh.
15 times 2 is 30, and you have $3.
15 times. Oh, we could. So we could buy 14 or 15 sparklers, right? Oh. So I can buy 14 or 15 sparklers when I buy no black cats. So here, I can add a point to my graph, couldn't I? I could add a point to my graph. I could buy 50. I did. Thank you for that, Daniel. And why would we buy just 14 when we could buy 15, right? All right, let's take a look at number 4. Number 4 says a tub is filled with 15 gallons of water and losing 1 gallon every hour. So we've got a tub with a leak in it, right? So A says write a function for the amount of water left in the tub after X hours. All right, so I'm going to let Y be the amount in the tub, so Y equals. How much water do I start with? 15 gallons. I'm going to say 15. And am I adding water or losing water? Losing. So am I going to subtract?
Yes.
Subtract what?
H.
8, XH. Well, X is the hours, right? So just X?
Yeah.
So minus X. All right. So is this going to be a discrete or a continuous relationship? Discrete? Continuous? All right. So I've got a couple of votes for continuous. So let's think about this, you guys. So I've got my tub. So here's my water level, right? Here at the top, this is the bottom of my tub. Am I going to just count every hour? And every hour, the water level is going to drop? Is that what happens? Really? So you're just sitting there, and an hour went by, and the water's all going to just like run out all at once?
Oh, no.
No, what's going to happen? Slowly over time, it's going to leak out, right? So, yes, if I'm looking at just every 1 hour, I lose 1 gallon, right? That's the rate that we're losing it at. But could I go and measure it at like 15 minutes?
Yeah.
After like 2 minutes? After like 30 seconds? So I could measure all of the time between now and when the tub is empty, right? So that would be continuous because it's always being measured. Is that okay? I saw the light bulb. Yes. Okay. So this one is going to be continuous. Do we need to say it again? Are you okay? Say it again. All right. So here, this one is continuous because in that tub of water, it's not going to jump down a gallon every hour, right? it's going to be slowly leaking out over time. Right? Is that better? There we go. All right, so C says label our coordinate plane, graph our function, and we're going to identify the domain and range. So my coordinate plane, I've got X are my hours, Y are my gallons. All right, this one I'm going to count every 5 tick marks, just to show it can be done on that way too. Well, wait. How do I know how much I need? What if I need more than 15? So let's make a table first, right? Because the last one we did, what, 15 was the most? And 10? Is it okay? Yeah. It didn't fall. We're good. Okay. I'm going to make a table. Here at the bottom I have X and I have Y. So at 0 hours, how much water do we have? 15. After 1 hour, we lose a gallon. So how much water do we have left? 14. After 2 hours, I lose another gallon. 13. After 3 hours, 12. So am I going to have the same pattern all the way until we're empty, right? Fantastic. So I'm going to have 4 is 11, 5 is 10, 6 is 9, 7 is 8, 8, 7, 9 is 6, 10 is 5. Am I going too fast? No. 11 hours, we'll have 4 gallons. 12 hours, we'll have 3 gallons. 13 hours, we'll have 2 gallons. 14 hours, we'll have 1 gallon. Am I going to stop there?
No.
So 15 hours, we'll have no gallons. Can I go to 16 hours? Why not?
No water.
Well, there's no more water to lose, right? You have sand in your tub? Okay. All right, so 0 to 15, from experience on the last one, we have plenty of space to count by ones, right? All right. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to go plot all of those points. Woo! So when x is 0, y is 15. When x is 1, y is 14. When x is 2, y is 13. So what's happening here to get to the next point? You just go down and over 1, right? Down 1 and over 1. Whoa, slope. Because what's the slope of that line? -1, right? So you're going to go down 1, over 1, down 1, over 1, down 1, over 1. Yep. You got it. But on this relationship, we said that it was continuous. So can I connect all those dots? Yeah, we can. Yes. What did I do wrong? Do I need to slow down? Okay. I'm going to connect my dots and then I'm going to pause. Oh, my line was terrible. That's okay. It's just a sketch, right? Just a sketch. It did a little. I got a little wiggly there at the end. Oh, it's a beautiful line. I like how pink it is. Looks good, looks good. Kaylee's still plotting points. We're good? Did you connect your dots? Connect your dots. Oh, lovely, lovely. Yes.
I told Faith she was cool, and she's like, oh, I know I am.
Hey. You know it. All right. So, we need the domain and the range now. What's my domain? All of the x's live between 0 and 15, right? 15 is my biggest x, 0 is my smallest x. So if it's... Ooh, but here we can have all of the numbers in between also, right? Because like I could have like half a minute. We can do inequality. So what's my smallest x value? 0 is less than or equal to x is less than or equal to 15. And my range? What's my smallest y value? 0 is less than or equal to y. And my biggest y value is 15, so it's less than or equal to 15. All right, this is my favorite part. We're going to talk about that in just a second. Ready? What? Hardest part, let's find out. It says, describe the meaning of the Y-intercept. So on my y-axis, what does that 15 mean? We have 15 gallons at 0 hours. So we start with 15 gallons, right? I'm going to say start with 15 gallons of water. Right? I said it was water. Yes. I don't know. Maybe the tub's filled with mud. I don't know. All right. Wait, I didn't say it was a bathtub. I just said it was a tub. Sand. 15 gallons of sand. There you go. Kind of assumed it was a bathtub, right? Be just like a tub. All right. E says, describe the meaning of the X-intercept. Oh, we can't see my X-intercept. Scoot. There we go. So what's my X-intercept mean? At 15 hours, we stop what? Losing water because we ran out, right? So at 15 hours, the tub is empty, right? After 15 hours, the tub is empty. All right. F. After how many hours will the tub have 10 gallons? So I'm going to go to my Y's at my gallons. At 10, that's 5 hours. G. Isaac, can you help me with this one? After how many hours will the tub have 5 gallons? I'm going to go to 5 gallons. How many hours is that? 10. Perfect.
Okay.
10 hours. All right. Mason, can you help me with the last one? After how many hours will the tub be empty? 15, because when we have 0, when we have 0 gallons, we're going to have 15 hours. No. All right. Now, on the front, you guys, you have 1 and 2. And then on the other side of the back, you have 5, 6, and 7. This is classwork, but it's going to be due. It is what you don't finish in class is homework.
Which is like homework.
So at the top, can everyone do me a favor? I want you to write the due date for me.
Tomorrow.
Due.
Monday.
Monday.
Yes.
September 26th. Don't forget. So do it now, and you can turn it in when you're done. That way you don't forget. Do not put this away, you guys. We're not done.